Hi, and welcome back to Sporty Math, the brother of Swati Maths. Today we're going to be learning about the law of sines and the law of cosines. First, we'll go to Jack to explain a bit more about what it is.
Hi, I'm Jack. Let's dive in. The law of cosines and the law of sines are represented by these equations. We use them to find the unknown sides and the unknown angles of a triangle. So the law of sines is that you have two angles over two sides. And so the A, B, and C are all equal to one another, so you can mix and match. So that's the law of sines. And the equations for the law of cosines, you have that A squared equals to B squared plus C squared minus 2BC cosine of angle A, or alpha. So, in specific, one way we can use the law of sines is if we have two known angles and one known side. So we have two known angles and one known side in order to find the unknown side. And with the law of cosines, we can find the unknown side with two known sides and one known angle. So we have the two known sides and the known angle in order to find the unknown side. Now I'll turn you over to Stephen for some real-world examples.
Welcome to the field. Right now, I'm at a local baseball field looking for some real-world examples using the law of sines and the law of cosines. Let's get started. So first, we'll look at an example using the law of sines. We have a triangle with angle B equal to 20 degrees, angle A equal to 82 degrees, and side B equal to 6. We want to solve for side A. So we'll write the equation as A over sine of 82 is equal to 6 over sine of 20 degrees. We first will cross multiply, so we'll get sine of 20 degrees times A is equal to 6 sine of 82. And we want to get A by itself, so we will divide both sides by sine of 20 degrees. So we get A is equal to 6 sine of 82 over sine of 20. And we'll put that into our calculator and get 2.058 as our side length. Now let's look at an example using the law of cosines, this time in the baseball field. Let's say we have a baseball pitcher at the mound. The distance from the mound to home base is 60 feet. The ball is pitched to the batter and made contact directly over the home plate. The ball is hit 180 feet at an angle of 30 degrees into right field. It is then caught by an outfielder, resulting in an out. That's unfortunate. The player then throws the ball back to the pitcher for the next pitch. How far does the fielder need to throw the ball back to the pitcher? Something you may want to know is that a baseball diamond is square, which means that all the sides are equal and has angles of 90 degrees. Remember this formula? C squared is equal to A squared plus B squared minus 2AB equal cosine of C. We'll put the known values into the equation to get C squared equals 60 squared plus 180 squared minus 2 times 60 times 80 times cosine of 30. After simplifying and using our handy-dandy sports portable calculator, we get the answer as 131.5 feet. That's a pretty good throw. Man, don't forget your calculator when you play baseball. That could save you the game. Thanks again, guys. Pretty great. A couple things to remember before you go. Number one is remember, understanding the angles can make a big difference. When using the law of sines and the law of cosines, try to solve for the largest angle first. When you do, it is greater than 90 degrees, then you know the other angles both must be acute. Number two is find which formula you need to use before you start. Don't make the mistake of using the wrong one. But if you do use the wrong formula, then you'll find out pretty quick because it won't work and it won't make any sense. But thanks again for tuning in, and make sure to join us next time as we continue to explore the fascinating connection between sports and mathematics right here on Sporty Math.